Similarity. What's with the hilarity in relation to similarity? So let's discuss what similarity is. This is an M1A1 Abrams tank, and it's seen service in Iraq and Afghanistan. This is also an M1A1 Abrams tank. It may have seen action on a shelf in your room because it's a model. So models are excellent real-life examples of similarity in action. Everything on the model is the same exact shape, but a completely different size than what's the actual tank is. The treads are the same width in proportion to what the actual is. All right, so we need some definitions here. A dilation is an enlargement of a figure or item. So if I take a small item and make it larger, that's a dilation. A reduction is the opposite of a dilation, such as what we see in our example with the model of the tank. The actual tank is reduced down, and then that becomes the model. Examples of dilations would be if we see a coronavirus and we blow up and make a model of that, right? Or a picture of it. It's much larger than what the actual virus is. Okay, so a pinhole camera produces a reduced image of a candle. The size of the image is proportional to the distance of the candle from the camera. Given the measurements shown in the diagram, find the height of the camera. So what we can do with this is we can realize that since we have a relationship of that the distances, all right, so distance of the short distance over the long distance is going to be relative from the heights, so the small height over the actual height. So now we can just cross multiply and divide like we've been shown. So I end up with 5h equals 40. So the height of the actual candle is 8 centimeters. Okay, so similar polygons. The definition of this is that similar polygons have the same exact shape, but not necessarily the same size. Okay, so two polygons are similar if and only if their corresponding angles are congruent and the corresponding side lengths are proportional. So the congruence makes the same shape. The side lengths being in proportion, that's what gives us our reduction or our dilation. So if we take a look at this, you'll notice just like in congruence, when we name similarity, that's what the symbol here means. That symbol, the tilde, means similar. ABCD is similar to EFGH. The corresponding angles, the congruent angles match up just like they do in congruence. So, corresponding angles will be congruent, and then the sides, AB over EF, BC over FG, CD over GH, and AD over EH would all have the same exact ratio of 2 to 1. So, awesome example time number 1. If triangle FGH is similar to triangle JKL, list all pairs of congruent angles and write a proportion that relates to corresponding sides. So how we would do this is we would say that angle F is congruent to angle J, and then angle G is congruent to angle K, and angle H is congruent to angle L. And then to set up our proportions, I would say that FG over JK is equal to GH over KL, which would then be equal to FH over JL. Oops, not KL. All right, so there's our proportions. Okay, and our congruent angles. Moving on. Okay, so the ratio of the lengths of the corresponding sides of two similar polygons is called the scale factor. This can also be called an enlargement ratio, a dilation ratio, or a reduction ratio. So we have triangle CAT, CAT, similar to triangle OGD. The scale factor of triangle CAT to triangle OGD is 16 over 4, which is 12 over 3, which is 8 over 2, which is 4. So the scale factor is 4. Since this is the triangle we named first, or the polygon we named first, is the numerator. The denominator will always be the one that's second. So you want to keep that in mind. This is the new, let's try adding the pen here. This is our numerator. Go first, and denominator second. All right, triangle MCN is a dilation of triangle MED with an enlargement ratio of 2 to 1 for each pair of corresponding sides. Find the lengths of the sides of triangle MCN. All right, well, this is not that hard to do, really, because if this has a length of 3 and this part here has a length of 6, so we know that's 2 to 1. So from here to here is 4, so from here to here is going to be 8. So now we've got to figure out what are the lengths of MC is, and we can basically just take and do a little distance formula here, and we're going to say that, oops, I don't even need all that, since we can use distance formula, or you can use Pythagorean theorem. We'll use Pythagorean theorem because that may be a little simpler. 6 squared plus 8 squared equals NC squared, right? And I end up with 36 plus 64 equals NC squared, which means 100 equals NC squared. And we take the square root of both sides of that, and we end up with NC is equal to 10. So they are 6, 8, and 10. All right, so the ratio, the perimeter of similar polygons theorem basically says the ratio of the perimeters of similar polygons equals the ratio of any pair of corresponding sides, or the scale factor, right? So if ABCD is similar to MNOP, then the perimeter of ABCD is in proportion or over the perimeter of MNOP is the same as the scale factors. So as we can see here that the scale factor is in fact 2 to 3. So the perimeter, all right, is going to be also 2 to 3. So in, let's say MNOP, you'll notice the perimeter there is 16. So that means that the perimeter of ABCD would have to be 24. And if we add all that up, we would in fact find that to be true. Okay, so given that ABCD is similar to EFGH with the measures we see as shown, first we need to find the lengths of FGGH and EH. Well, so our scale factor is easy to see here that is going to be 6 to 9. So 6 to 9, that reduces to 2 over 3. So now we just do this, excuse me, with every single side that's remaining. So AD is 7, so 2 over 3 is going to be equal to 7 over EH. So we end up with 2EH equals 21. So that's going to turn into 21 halves. So EH is 21 halves, or we could say 10 and a half. Okay. Let's do the next one, which would be CD. So GH. So CD is 3, so 2 over 3 equals 3 over CD. So 9 is equal to 2 CD, so CD would equal 9 halves, or 4 and a half. And then BC is 2 over 3 equals 4 over FG, right? Well, 2 over 3, so that's 12 equals 2 FG, so FG is equal to 6. So what's the perimeters? Well, it's going to be the same as this, so that's nice and easy, 2/3. Oops. Let's go back here. This whole thing is going to be equal to x plus 15. So 9 over 12 is our scale factor, so that's going to be equal to 3/4. So now we know that 3 over 4 equals 15 over x plus 15. So cross multiply, I end up with 3x plus 45 is equal to 60. 3x would equal 15, therefore x is equal to 5. In this diagram, segments PA, PB, and PC are drawn to the vertices of triangle ABC from an external point P, then extended to 3 times their original lengths to points A prime, B prime, and C prime. So, what are the lengths of A prime, B prime, or the sides of A prime, triangle A prime, B prime, C prime? So, the original part is extended out 3 times from P. So if A prime, B prime, okay. So what we want to figure out here is if AB is 12, then basically AB over here has to be 3 times that, or 36. This is 10. This has to be 30. And this has to be 45. I just wanted to make sure I was looking at that properly. Okay.
That's all, folks.
Later.